Okay, so for section 10.3, using chords, we're talking about some different relationships in them. So the first one, if you have a chord, which this is our chord, and it's perpendicular to the diameter, so if it's a right angle here, then the chord is bisected. And so that means this would be 5 and this would be 5. Okay? Be aware that you're probably going to have to also do some problems with a radius and Pythagorean theorem. Okay? So just be aware that you might have to use something with a radius and Pythagorean theorem with a right triangle there. But the key for this problem is that that chord gets cut in half. Okay? The next one we have is if two chords are equal distance from the center, and so that's the chord ED and the chord CB. If they're equal distance from the center, so if this distance is the same as this distance, and when you measure distance, it's a right angle, so we're throwing in more right triangles. If those two things are true, they're right angles and they're the same tick mark, then that means that this line, E to D, is the same as this line, C to B. So they are congruent. Let's fill in that word. And again, there's a good chance you're going to have a swinging radius or a radius there to form a right triangle. Okay, the third rule we have is that if in the circle you have two chords that are congruent, so if these two chords are congruent, then that means that the arcs made by those chords, so AE makes chord AE and DC makes chord DC. If those chords are congruent, then that means the arcs are also congruent. My picture might be drawn, it might be off a little bit because one looks shorter than the other. But again, the rule is that those would also be the same. Okay, so let's use this information we have to solve some problems. Okay, so the picture's a little small, but we'll see what we can do. So the measure of W to X, so right here, this arc right here. Okay, so looking at information, it's going to be the same as this angle because central angles are the same. Well, this 42, it's hard to see it, but that 42 is there. So if this is 42, then this angle's 42 because of vertical, and then the arc WX is also 42 because of the central angles. Okay? All right, let's go ahead and erase that information because that makes it hard to see. Okay, and then let's start fresh with number 2. W to Z. Okay, so W to Z right here. Well, if those angles are equal, then that means this is 42, which we knew. And to find this one, X to Y, we do 180 minus 42, which is 138. But it would also be 138 here. So since I have this, let me highlight it so you could see it. Since I have this arc on the left and it equals this arc on the right, then that means that this chord on the left that makes that arc is equal to this chord on the right that makes that arc. So since X to Y is 9.2, then W to Z is 9.2. And that's a little tricky to see, but hopefully you kind of understand what I did there. Okay, so now what I'm going to do is I'm going to erase those things again so you can see it, because there's a lot of information on that picture. Erase, 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 erase. There we go, all clean. Okay, so now let's look at the next one. Y to Z. This right here, Y to Z. Well, this is 42 again. And this is 42 again. So that means those chords are equal, similar to what we did there. So Y to Z is also 3.6. Okay, and then the last one, let's erase one last time. The last one, oh, don't want to do that. Hit the wrong button. X to Y, and we actually talked about that a minute ago. Since we know that this arc is 42, these two arcs together make a semicircle. So 180 minus 42 should be 138. 180 minus 42. Yeah, 138. I always have to double check my math so I don't make mistakes, and then people are writing comments saying I made mistakes. Okay, questions on that? So it's a lot of information there, but just take it one step at a time and it's not that bad. Okay, let's look at this next one. Okay, so what I have is I have a chord right here that's perpendicular to the diameter. And so that means that these are equal. So I'm just going to set those two things equal. 2x minus 4.1 equals x minus 0.5. So I'm going to minus an x on both sides. And so now I add a 4.1 on both sides. And I get a, oops, that's a negative. So I forgot to bring that negative down. And so I'm going to get a 3.6. Okay, so it's a lot of work there. It looks like it's a complicated problem, but if you know that if I have a diameter is perpendicular to a chord, then remember it bisects the chord. Okay, why don't you try number 6, and when you think you have it, press play. So you should have recognized it was the same thing. It was bisected, so it's just going to be 3x minus 5 equals 2x plus 1, minus 2x on both sides. And then add 5 on both sides and you get 6. Okay, so that rule is not that tricky, it's just one you have to remember. Alright, next one, we need to find the radius. Okay, so both of these problems don't have a radius drawn. So I'm gonna actually draw the radius in red. R for radius in red. Okay, so there's a couple things I have to do. If you notice, I'm gonna have this triangle. I'm taking that out right there. I know the base is 3. I don't know the radius, so I'm going to call it R. I need to find this. What I do know, what I am given, is I'm given that this whole thing is 5x minus 2. I don't want to have an x with an R, so I need to solve for x somehow over here. Well, I have two chords that are equal. So I'm going to go ahead and solve that because I know they're the same. So 5x minus 2 is 3x plus 2. So that's going to give me 2x is equal to 4 because I'm going to add 2 on both sides. So that tells me x is 2. Now that still doesn't give me the answer here. What I need to do now is plug it in. So 5 times 2 minus 2. So that tells me that this whole thing right there is 8. But I don't need that whole thing. If you notice, I colored just this. I need this piece. Well, that's this piece here. What is that piece? Well, if the whole thing is 8, then that top piece is just 4, because remember, it's bisected. So now I can do Pythagorean Theorem. 3 squared plus 4 squared equals r squared. And now I'm going to solve. So 9 plus 16 is r squared. So r squared is 25. If I take the square root of both of those, r is 5. Okay, so it was a lot of little information to do. Remember, you're going to have to swing the radius, but I could tell you probably 90% of the time on these problems, you're going to have to do Pythagorean Theorem. So you're going to have to look to find the right triangle and then find enough information for it. Okay, so now let's look at number 8. For number 8, I need to find the radius, so I'm going to swing a radius here again. And so I'm going to take that triangle and draw it. And I don't know what R is. Now if you notice here, let's change colors. I know that this whole thing is 20. So then what's this part right here? It's not the whole thing, it's just the top part. And that's right, it's just 10. So I'm going to put a 10 here. What I need to find is this, right here. Okay, and again, I don't want to have an X with an R. It makes it way too hard. So, but look, these things are equal distance. So I should be able to set those two things equal to each other to find that. So I'm going to subtract an X on both sides, and I'll get 3x minus 5 is 4. Add 5 on both sides and get 3x is 9. So x is 3. So, oops, I don't know why I circled that in. I don't want to circle that. So now I'm going to plug that in here. So 4 times 3 minus 5. Well, that's 12 minus 5, which is 7. So this is 7. So a lot of work just to be able to set up a problem to do Pythagorean Theorem, which is now more work. So 7 squared plus 10 squared is equal to r squared. So 49 plus 100 is r squared. And so r squared is 149, so I take the square root. And so that should be 12 point something. Let's just double check. It's 12 point maybe 2. I'm just guessing. Oh, clear it out. Square root of 149, 12.2. Okay, so you have to remember when things are equal. You have to remember when things are bisected, and then you have to be able to make right triangles. And again, you are going to have to make a lot of right triangles, so make sure that you can start visualizing them and you swing your radius to make that right triangle.